Today we're going to be focusing on analyzing graphs, and the goal of the lesson is to interpret quantitative relationships represented as graphs without numbers. And what you're going to notice is you have to look at two things. You're going to have to look at the y-axis, and you're also going to have to look at the x-axis. And there's also going to be a title on top, and you'll see in the next examples what that title is. And it's talking about how to describe using distance and time. Now, it might be time is always, or like months or years is always going to be at the bottom, whereas distance or something that's changing is going to be on the side. And some words you're going to see is that this is going to be something that a line that's facing this way is going to have increasing data. This is going to have what's called no change, or it's going to remain constant. So if you were driving like the same speed limit, it would show like you're driving 40 miles per hour at a constant, then that's why it's a straight line. Also, if you were like braked at a stop sign, your time would keep going, but you would remain constant, and if it was down at the bottom. Also, this is showing a line that's decreasing. This is something that it's going up by a constant rate. You might see increasing or decreasing gradually happening, or you might see something where there's an extreme increase or decrease, like it's going to be that it's quickly increasing or quickly decreasing. So you're going to see a lot of different things, but these are kind of the terms that you want to use when you're describing your graphs. Now, an example of this would be if we're talking about an airplane and we're talking about the altitude and the time. So what happens in this graph is as we take off, so this is the starting point where it's basically on the ground. If you think about altitude, it goes higher as the plane goes up. It's increasing. So after the takeoff, the altitude of the plane increases at a constant rate. So that's this point. Then remains constant for a time. So basically it's flying in the air at a certain altitude, and then it decreases at a constant rate until the plane lands. So now it's at an altitude where it's on the ground, so that is your decreasing. Another example of this would be if we're talking about a car. So we're talking about the value of the car and the time. So what happens here is the value of the car decreases quickly at first and then more slowly. So this is actually what's called exponential decay. This would be something that's nonlinear, and you can kind of see how it's decreasing and then it slows down a little bit. This example is about test scores. So you can see we're talking about the score of the test and the time. So test scores increase at a constant rate as the time goes on, is basically what happens, is that scores increase as time goes on. My last example is going to be sales. So in this case, we're talking about money or dollars and time. So the amount of money in sales decreased at a constant rate and then remained constant. So if they were selling something, their sales decreased, and then once it got to a certain point, it just remained constant. So nothing was changing. So there was no change. It remained constant.